The atom, a tiny yet incredibly complex structure that forms the foundation of everything we see, touch, and experience in our daily lives. The fundamental building block of all matter. From the air we breathe to the stars in the sky, atoms are the essential units that make up the universe. For centuries it remained an enigma, its secrets hidden deep within its core. Ancient philosophers and early scientists pondered its mysteries, laying the groundwork for future discoveries. Then, in the 20th century, humanity unlocked the atom's power. Pioneers like Einstein and Bohr revolutionized our understanding, revealing the atom's inner workings and its immense potential. This discovery, a pivotal moment in our history, brought forth both unprecedented potential and unimaginable peril. The world stood on the brink of a new era, filled with both hope and fear. The splitting of the atom, known as nuclear fission, unleashed a force never before witnessed on Earth. This process, which releases a tremendous amount of energy, changed the course of history. This power held the promise of clean, limitless energy. Nuclear reactors began to spring up, offering a new source of power that could potentially end our reliance on fossil fuels. But it also gave birth to the most destructive weapon ever conceived, the atomic bomb. The devastation of Hiroshima and Nagasaki served as a grim reminder of the atom's dual nature. The story of nuclear fission is a tale of scientific brilliance, global conflict, and the enduring responsibility that comes with wielding the power of the atom. It is a narrative that has shaped international relations and continues to influence global policies. It is a story that continues to shape our world today, reminding us of the delicate balance between scientific progress and human choices. As we advance, we must remember the lessons of the past. The future, as we stand at the cusp of a new nuclear age, hinges on our wisdom and our resolve to harness this power for the betterment of humanity. The choices we make today will determine the legacy we leave for future generations. To comprehend the sheer force of nuclear fission, we must journey into the heart of the atom. Imagine a miniature solar system. At its center lies the nucleus, composed of protons and neutrons. Orbiting this nucleus are electrons, tiny particles of negative charge. The nucleus, though infinitesimally small, holds the key to atomic energy. Bound within the nucleus is an immense force, the strong nuclear force, holding protons and neutrons together. When this bond is broken, a tremendous amount of energy is released. This is the essence of nuclear fission. By splitting the nucleus of an atom, typically uranium or plutonium, we unleash this bound energy, creating a chain reaction of splitting atoms. The energy released is millions of times greater than that of any chemical reaction. This power, once unleashed, can be harnessed for good or for ill. The year 1938 marked a turning point in human history. In a Berlin laboratory, a team of scientists, Otto Hahn, Fritz Strassmann, Lise Meitner, and Otto Frisch, achieved what was once thought impossible. They split the atom. Their discovery, born from years of meticulous research and experimentation, was nothing short of revolutionary. Bombarding uranium with neutrons, they observed lighter elements as byproducts. Meitner, a brilliant physicist forced to flee Nazi Germany, provided the crucial theoretical explanation: the uranium atom had been split, releasing an immense amount of energy. The world, on the brink of war, took notice. The implications of their discovery were staggering. The power of the atom, once a theoretical concept, was now a tangible reality. And with this realization came the chilling possibility of a weapon of unimaginable destructive force. Section 4. The Manhattan Project, a race against time. As World War II raged, a sense of urgency gripped the scientific community. The world was engulfed in conflict, and the stakes had never been higher. Scientists and military leaders alike understood that the outcome of the war could hinge on a single devastating weapon. The news of nuclear fission had reached the United States, and the fear that Nazi Germany might develop an atomic bomb first spurred a top-secret research endeavor, the Manhattan Project. This project was not just a scientific challenge, but a race against time, with the fate of the world hanging in the balance. In 1942, under the leadership of General Leslie Groves and physicist J. Robert Oppenheimer, the Manhattan Project brought together the brightest minds in physics and engineering. These individuals were tasked with an almost impossible mission: to harness the power of nuclear fission and create a weapon of unprecedented destructive capability. From Los Alamos to Oak Ridge, secret cities sprang up across the United States, dedicated to the single purpose of building an atomic bomb before it was too late. These cities were shrouded in secrecy, their true purpose known only to a select few. The challenges were immense. The scientists and engineers faced numerous technical hurdles, from refining uranium to designing a bomb that could deliver the desired explosive power. Every step of the process was fraught with difficulty and danger. The science of nuclear fission was still in its infancy, and the engineering feats required to build a workable bomb were unprecedented. The team had to innovate and experiment, often with limited information and under extreme pressure. Yet, driven by the urgency of war and the fear of a Nazi victory, the scientists and engineers of the Manhattan Project raced against time, their work shrouded in secrecy. They knew that failure was not an option, and their relentless efforts would ultimately change the course of history. Section 5. Trinity, where the sun was forged on Earth. The arid plains of New Mexico became the proving ground for this monumental endeavor. It was here, amidst the vast and desolate landscape, that a team of brilliant minds gathered to change the course of history. The isolation of the desert provided the perfect backdrop for an experiment that would alter the world forever. In the pre-dawn hours of July 16, 1945, the world held its breath as the first atomic bomb, nicknamed Gadget, stood ready at the Trinity test site. The silence of the early morning was a stark contrast to the impending chaos that was about to unfold. Scientists and military personnel alike were acutely aware of the significance of this moment. The anticipation was palpable. Every second that ticked by felt like an eternity. The air was thick with tension as final preparations were made. Faces were etched with a mixture of fear, excitement, and uncertainty. This was uncharted territory, and the outcome was anything but certain. No one, not even the scientists themselves, could fully comprehend the forces they were about to unleash. The Manhattan Project had brought together some of the greatest scientific minds of the time, yet the true power of the atom remained a mystery. They had theoretical knowledge, but the practical implications were still unknown. At 5:29 and 45 seconds a.m., the desert sky erupted in a blinding flash of light. It was as if a second sun had been born on Earth. The intensity of the explosion was beyond anything anyone had ever witnessed. The light was so bright that it could be seen for miles around, turning night into day. The ground trembled as if shaken by a giant's hand. The sheer force of the explosion sent shockwaves through the earth, rattling everything in its path. It was a visceral reminder of the raw power that had been unleashed. The observers could feel the ground beneath them quaking, a physical manifestation of the energy released. A mushroom cloud, towering miles into the sky, became an ominous symbol of the atomic age. This colossal plume of smoke and debris was a visual representation of the destructive potential of nuclear energy. It was a sight that would be etched into the collective memory of humanity, a stark reminder of the new era that had dawned. The Trinity test was a success, a testament to human ingenuity, and a chilling harbinger of the destructive power now at our fingertips. The scientists and military personnel celebrated their achievement, but there was also a sense of foreboding. They had unlocked a force that could bring about unprecedented destruction, and the responsibility weighed heavily on their shoulders. The world had entered the atomic age, forever changed by the blinding flash in the New Mexico desert. The landscape bore the scars of the explosion, a stark reminder of the power that had been unleashed. The implications of this new era were profound, affecting not just the present, but the future of humanity. The genie was out of the bottle, the power of the atom unleashed. This newfound power held the potential for both great advancement and unimaginable destruction. The world would never be the same as the shadow of the atomic age loomed large over the future of mankind.